We will now see chain of thought. Chain of thought is one of the recent incorporations in the design of large language models. So here we have uh, multiple uh, multiple examples of our approaches. So this without chain of thought. So for instance, let's say that we pose the LLMA problem, like if a farmer has 3 cows and each cow gives 4 liters of milk per day, how much milk is produced in 5 days? So the network produces 12 liters, that is incorrect. So the zero shot prompting with chain of thought is trying to promote step by step thinking. So we pose the same problem, but we propose let's think step by step. So step one, each cow gives 4 liters per day. Step two, there are 3 cows. So in one day there is 3 times 4 liters, 12 liters per day. And then in step 3, over 5 days, we have 12 times 5, that is 60 liters. Okay, so zero shot prompting, what it's doing is producing a step-by-step thinking. A few shot prompting would be we give reasoning examples. So we will ask about the farmer and the cows and the milk, but before doing that, we are giving examples of reasoning. So Tom bought 3 packs of pencils, each containing 5 pencils. How many pencils does he have? So then the answer that we have to give is, okay, let's think step by step. Each pack has 5 pencils. Tom has 3 packs, so the total number of pencils is 3 times 5, that is 15. So we are giving examples, reasoning templates, and these reasoning templates are supposed to be related to our final query. And we can compare this chain of thoughts with a new approach that is called tree of thoughts. So we have the no change of thought, no thought reply, that is input, and then we produce an output. Then we have the chain of thought prompting, in which there are multiple intermediate steps. Each step can be thought as a thought, so it can be considered to be a thought. Then we have self-consistency change of thought. That is, we have multiple reasonings, and then we compute kind of average or majority vote or whatever of the different outputs to produce our final output. And this tree of thoughts is a different approach. So we have from the input we have multiple thoughts. These multiple thoughts, they might have different probabilities that are somehow represented here by the color, and then each one of the thoughts can generate more subsequent steps, and then the tree of thoughts evaluates the current thoughts and decides what to explore next. So an advantage of that is that it has a higher computational cost, that is bad, but it can backtrack and reconsider. So because it has a tree, it can go back through the tree and decide to explore some other branch. That is something that cannot happen in the chain of thought. So the reasoning, the chain of thought is linear, so it can get stuck in some incorrect reasoning. And here we have from that paper that I gave you before. From that paper we have a table in which we see how this tree of thoughts has been used to solve different tasks. So a game of given 4 numbers, how to get to 24, or creative writing of crosswords, so we can get an idea of how these things are used. Sometimes we want our large language model to produce an output that has some structure. It cannot be free form. So, for instance, we may want the network to generate an SQL sentence. So, for instance, select name, comma, email from customers where country is equal to USA. So the thing is that the large language model generates words using the logics and the standard way that we have seen so far, but then we have some logic processing. So from this proposal, we have to go through some rules. So, and then these rules say, for instance, if you are at the starting of the output, then the only possibilities are select or delete. You cannot put name or email or ID or whatever. And if you have chosen select, then the name word can be name or email or ID. So you give some rules, and then from these rules you can filter out part of this example. So let's say that we have at this point we are here in time. These are the possible outputs, but then after processing with the rules, some of the words are excluded. So now we have only 2 possibilities. So we have select name, and then after name, what comes next can may come comma or may come from, but it cannot come select again. So we have seen some more examples. Let's go to the next.